Okay, hey guys, welcome back to week 14, the last week of classes. Today we're going to basically finish chapter 5. I might have to leave one or two little tiny things for the end, and then we'll get into the final chapter tomorrow. So one thing before I get this slide started, I need to go back and review, or not review, but just remind you of what we did on Thursday. On Thursday, we did this practice problem. Okay, and we answered it. We found out that the mass of this product was 8.772 grams. Okay, so we did this on Thursday. What this means is, or what this term means is, this is something called a theoretical yield. Okay, this is what we would make in a perfect world. So again, going back to this question that we did on Thursday, we used math, pure math, no experiments, no chemicals. We used basically a concept called stoichiometry, but in simple words, we used mathematics to predict how much mass of product we would get. What would the mass of product be? We calculated that if everything went perfect and every mole was accounted for, every gram, every mole, we would get 8.772 grams. This is called the theoretical yield. This is the chemical you make or this is the amount you would make in a perfect ideal situation. Now, we know real life is far from perfect, and especially in the labs, very far from perfect. And in most of your labs, you guys have been asked in the conclusion to list a source of error. There's a reason for that. The source of error is a reason why, for example, a yield might be low. Your product, you might get less than you think. This is based on error. Okay, so the little note down here, if you did this reaction in the lab, would you get exactly 8.772? No. I don't know why I put a question mark there. You definitely wouldn't. You know, something might be left on a stirring rod. You might put this through a filter and lose some chemical in the filter paper. The reaction might not go to completion. Maybe it needs to be warmer or something. Like, there's so many reasons here. So your actual yield is typically lower than the theoretical yield for a few reasons. These are just some of the reasons. Now, you'll laugh because the first one is one that we don't typically accept in a lab report. Human error is honestly probably one of the biggest reasons why your yield would be lower. Now, this is not a source of error that we take in the lab, because if you calculated something wrong, if you spilled a chemical, if you put in the wrong chemicals, that's your fault. And it definitely lowers the actual yield. But in the lab, we're looking for issues with the experiment. And issues in the experiment can be like, problems with equipment. For example, you could lose some of the chemical when you're trying to filter it or purify it. Sometimes chemical reactions have side reactions. Maybe it's not reacting like you think it is. Maybe the chemicals aren't pure, right? You guys can't control that. You don't order the chemicals. So maybe the chemicals are old or out of date. Another one is equilibrium. This you'll do in Chem 2. Not something you need to worry about for this course, but there's lots of reasons why your actual yield might not be as high as theoretical. And again, unfortunately, the typical reason is because a human messed it up. You spilled something, did something you weren't supposed to. So this is basically one of the last topics of chapter 5. This is really the only new thing you're going to learn for the end of chapter 5. Very straightforward. When we can calculate a theoretical yield, and when you go to the lab and you do the actual experiment, sometimes what your boss or professor or instructor will look for is something called the percent yield. You can think of this like the percent that you get on a chemistry test or chemistry lab. It's a percentage. The actual yield is the what you actually got when you did the test or quiz. The theoretical yield is basically what the test is marked out of. It's in theory, theoretically, this is the maximum amount of marks you can get. And then you times it by 100. So just imagine, you got a test back in a course and it was like, I don't know, you got 20 out of 25 on a test. Well, the 20 is your actual mark or grade. The 25 is the theoretical grade, meaning that's the highest you could get in theory. And chemistry is the same thing. The actual yield is what you actually get in the experiment, and theoretical is what you get in theory, if everything was perfect. So here's a little quick example here, and we're going to do more of this today, I promise. I have a bunch of examples for us today, which is why we might not finish, but it's definitely good practice. In the last reaction, only 8.13 grams of Na2O was made. What is the percent yield? Now remember, this is the last reaction, the reaction we were just looking at. So my percent yield is what you actually get in the lab. So a key word, guys, or a key hint is when you see the word lab or made in the lab, that's your actual. Okay, if there were no calculations involved and we give you the mass, that's actual. It's called the actual yield. It's what you make, what a human actually makes. So it's 8.13 grams. The theoretical yield was 8.772 grams. And we multiply it by 100, and that's it. Now, for anybody just joining in, or maybe you're a little sleepy or tired, I know it's been a long semester. This came from the last question. This was the answer. Oops, sorry. This was our theoretical yield for the last question. Sorry about that. My screen went all weird. So this, let me pick a different color here. This is from last question. Okay, we're going to do one of these in a few minutes. Don't worry. It's really fun, actually. It's kind of, well, okay, maybe fun is the wrong word, but it's really easy and it's pretty interesting to do as well. So when I do this, I can have three significant figures. I get 92.7%. Okay, so I mean, imagine if you got 8.13 out of 8.77 on a test, you would get a 92 or 93%. Well, in chemistry, it's the same thing. Our yield is about 93%. So that means roughly 7% of this was lost. And it might not be your fault, right? It might be the chemicals didn't completely react. Maybe, they were impure. Maybe you lost some during filtration. I mean, you can't avoid some of these things. But this is a very important concept for any of you guys interested in going further in chemistry. Definitely very important. Oh, the answer was already written there, but you can see I like to write it myself. Okay, so let's do this question now. Here's what I'll do. I want you to kind of relax and don't panic if you have no idea what to do. But what I would love to do is give you guys just a couple of minutes to try this. This, wink, 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 is definitely a final exam question. So make sure you know this. We've actually already done this type of question. This is nothing new. It's a three-step problem. So here's what I'll do. I'll kind of give you guys some hints. I'll set it up for you, and then I'll kind of put myself on mute and give you guys 5 minutes to do this. So first things first, what is the mass of H2? So I'm looking for mass when you have 5 grams of NH3. Okay, the molar masses are given. That's excellent. So that's question A. And then B says, what is the percent yield? And they give you the actual yield here. Yield, by the way, I might not have explained what that term meant. Yield means like what you get. Yield is like a product, from math or from a lab. Now, I'll give you a couple hints here for anybody who really doesn't know what to do. In part A, step number 1, you need to find the moles of the chemical you're given, which is NH3. Step 2, use your mole ratio to find the moles of H2, what you're required. And then step 3, answer the question, find the mass of H2. There's only one formula you need to know today. Moles is mass over molar mass. Okay, mole ratio is not really a formula, it's just a conversion. So I'm gonna stop talking. I'll be back at 2:50 in 4 minutes, and we'll see if you can get A. If you guys can figure out A, I will be a happy man. So I'll be back in 4 or 5 minutes. See you soon. Any questions, let me know in the chat. Okay, so guys, let's check very quickly. Let's look at the answers for this because I am getting some of the right answers in the chat. So, okay, let me read the question first, and then I have to write this on another slide because I do not have enough room. So question A, what is the mass of hydrogen produced from this equation if you have 5 grams of NH3? Okay, pretty easy. And then B, what is the percent yield if you only make 0.75 grams in the lab? So part A, well, first things first, always start with a balanced chemical equation. It was certainly balanced already. Oops, I'm doing the wrong one. Sorry, I'm doing the one that we're going to do next. So 2NH3 goes to N2 gas and 3H2 gas. Okay, so this is balanced. Now what I like to do is under each of these, it'd be nice to write like the information I know about each chemical. So I know that for NH3, I have 5 grams. I also know that the molar mass is 17.0305 grams per mole. And for the H2, I don't know the mass. That's what I'm looking for. And the molar mass is 2.015. Whoops. 88. These are from the question. These are just molar masses from the question. Okay, so let's go very quick. Let's get this one done. Part number 1, find the moles of the chemical that you are given. So that's NH3. It's mass over molar mass. Okay, so I'll do that on my old calculator here. Just give me 1 second. So 5 divided by 17, but I am going to keep some significant figures in there, of course. So I get 0.29359 moles of NH3. Step number 2, find your moles of H2 using your mole ratio. So 0.29359 moles of NH3. But I don't want moles of NH3. I want to find the moles of H2. So that's 3 moles of H2 over 2 moles of NH3. Okay, you can see that I put the chemical I want on top and the chemical I don't want on bottom so that they cancel out. If any of you guys are wondering, where did that 3 and where did that 2 come from? They come from my reaction. Okay, it's my balanced chemical equation. So, I mean, there's a reason why last week we spent so much time balancing, because you need to have balanced chemical equations to do this. So, do this, multiply it by 3 divided by 2. I get my answer, 0.44039 moles of H2. And now I can answer the question. The mass of H2, this is my theoretical yield. It's moles times molar mass. Okay. We'll get my answer. The reason I love these so much is you can leave all of your numbers in the calculator. So as Aman said, I get 0.888 grams of H2. This is my theoretical yield. anytime you do a calculation using math, it's a theoretical yield. So part B, my percent yield, is to take my actual 0.75 grams over my theoretical and times by 100. Now remember, this 75 came from the question. Okay, so that if anybody's wondering where this came from, it came from the question itself. We have to give you the actual yield. I mean, you're not going to go into the final exam and do an experiment, right? We can't have that. So I get, oops, let me change to my pen. 84%, as Aman said, perfect. Two significant figures, 84%. If you guys did the calculations and said 85%, that's also acceptable. It's very, very close to 85. But with the numbers I'm using, I'm getting 84%. Whew, okay. Almost done for today. Just give me a little bit more time to introduce the last topic. It's pretty straightforward. We actually do not have to learn anything new. We're just going to apply what we already know to a different situation. All right, everybody cool? Any questions before I move into the next part? Pretty quiet. The other class was pretty quiet today too. I mean, we're all pretty much burnt out. It's the end of the semester. We've had 14 weeks, so we're almost done. Iman, the question was, in your final, will you have a balanced complete reaction? You are expected to know how to balance chemical equations. Let me just see something here now. I can help you out here. So you obviously you are expected to balance chemical equations, but for this type of question, stoichiometry, it's already been balanced for you. So yeah, it's already been balanced for you. Okay. So that should answer your question, Iman. You will have to balance a couple of equations in this test or in your final, but when you get the question like about stoichiometry or theoretical yield, actual yield, it's already been balanced for you. Which is good because it saves you a lot of time. I'm looking at it now. We even give you the molar masses. So basically, wink, 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 this question is exactly like the type on your final. We give you the balanced equation, we give you the molar masses, you just have to do the rest. So slide 84, definitely make sure you know. All right, cool. Let's go to the last topic of chapter 5. The final is in the gym on paper. The final is on campus in the gym on paper. None of your final exams should be online. We are not allowed. Okay, so there's one little problem I haven't really told or mentioned to you guys about this. We're kind of dealing with this ideal situation where we have one chemical we're looking at and we just assume that the other chemical is in excess, meaning we have extra, we have lots of it. But that's not necessarily true. Honestly, when you're doing something like I use the example in this morning's class, when you're like baking, you typically have a chemical, I'll say a chemical, an ingredient that will run out first. So like imagine you guys are making a cake and the cake says you need like 3 cups of flour, 1 cup of sugar, and 4 eggs. Well, imagine you're making that cake in the kitchen or in your kitchen, obviously, and you realize you don't have 4 eggs. You only have 3 eggs, or you only have 2 eggs. Well, that is going to limit the amount of cake you can make. So we have a term for this, and it's called the limiting reagent. So let me explain with this example here. You have 15 grams of aluminum, but you can only find, okay, so let's write that down. We have 15 grams of aluminum, but you can only find 35.76 grams of copper 2 chloride. And we're trying to make, remember, if you go back a few slides, the question was, we're trying to make, some copper here. The goal, we did this a couple slides ago, but the goal was to try and make 50 grams of copper for our boss. Okay, so we have 15 grams of aluminum in the lab. We have 35.76 grams of copper 2 chloride. Question is, could we still make 50 grams of copper? Well, there's a thing here, something we need to consider. In a reaction where you have 2 or more reactants, it's rare that we have the exact mass of all the chemicals needed. Usually, you'll have more of one than the other. And the chemical that you have more of, the chemical you have extra of, is called the excess reagent or excess reactant. This chemical you have extra, there'll be some left over at the end of the reaction. You can also think about this if any of you like to burn candles. Okay, so like when you're burning a candle, the candle is obviously composed of the candle wax, which is a hydrocarbon, and the wick. But you guys know that a combustion reaction requires oxygen. So if what runs out first when you're burning a candle? The oxygen in your bedroom or the oxygen in your living room? Or the candle wax, like the thing the candle's made out of? Well, obviously the candle runs out first. If you ran out of oxygen, you wouldn't be able to light a candle in your house or you'd die. It would burn all the oxygen in your room, but it doesn't do that. So when you're burning a candle, the oxygen required for combustion is excess. You have way more oxygen than you need, and the limiting reactant is the one that does run out first. This is the chemical you have the least amount of. Now this is really important. Why am I explaining this to you? The limiting reactant is what determines how much product you will actually make. Again, you can think of that kitchen example where we're making eggs. If you only have 2 eggs in your kitchen, but you have like a ton of flour and a ton of sugar, well, obviously the eggs are going to limit how many pancakes or cupcakes you can make. If you were cooking a feast, a meal for like 10 or 12 of your friends, but you only had like 1 chicken, that's obviously going to limit how much chicken you can make, right? So in chemistry, we have the same thing. So we're going to look at this problem now. This is already done for you, which I don't particularly like. I like to do one with you. So what I'll do is I'll very quickly show you this one. Like, again, the workings are there for you, but then I'll do the other one with you. I'll at least do the first part of it to kind of get you guys started. Okay, so what is the limiting reactant in this situation? Now, remember, we had 15 grams of aluminum, and we had, what was it, 35.76 grams of copper. Now, this looks crazy. Like you're looking at the slide, there's so much writing here. It's honestly not as bad as you think. What we do, and I was mentioning this to the other class, I've been teaching this for so long, for so many years, that I've tried all the tricks, all the tips, and I've tried every method, and this is the best I've found. This is nothing new. What we're going to do is the same method we've always been doing, but we're going to do it twice. So the method is step number 1, you find the mole of the chemical you're given. Step number 2, you find the mole of the chemical that is required, the chemical you're looking for. Step number 2 is done with mole ratio. Step number 1 is mass over molar mass. That's it. The reason there's so much writing on this slide is we do it 2 times. You do it for each reactant. We're going to do it for aluminum and we're going to do it for the copper 2 chloride. The reason you do it 2 times is you are trying to see which chemical makes the smallest amount of product. And again, you can see the calculations here. If we're talking about aluminum, okay, so using aluminum and doing our calculations, whoa, I didn't mean to do that. Let me pick a better color than purple. So using aluminum, we can make 0.8 moles of copper. And I'm going to show you these calculations on the next slide. Using copper 2 chloride, we can make 0.26 or we'll say about 0.3 moles of product. Copper 2 chloride produces the fewest moles of product. Therefore, it is the limiting reagent. So again, there's really nothing new here. We do the same calculation 2 times, and whichever makes the lowest amount is the limiting reagent. So our limiting reagent is here. It's the copper. It makes the least amount. Remember, I'm comparing these two numbers on the bottom. Using that number and going forward, I can then answer the question. So we will use the moles of copper from the limiting reagent. So I use the moles that I calculated, and I multiply my molar mass, and I am done. Okay. Confused? Everybody's probably confused. That's fine. Let's do one together. And what I'll do, because it's almost 10 after 3, I'm going to set this up for you. I'm going to do part A. And then I'll get you guys over tonight to maybe practice B and D. B and D are, we did this all today. The challenge is for you guys is how do we find the limiting reactant here? Iman brings up the question. Let me just go back. The mole of copper is the same as CuCl2. And the answer is yes, but that's because the mole ratio was 2/2, which is 1. Let me just pick a different color here, Ben. So because my mole ratio was 2/2, it is the same. That's just because that's only a coincidence. That hasn't, it's just because this is how that chemical reaction is. But it is the same because our mole ratio is 2/2. Oops. Actually, oops, that should be 3/3, not 2/2. 3/3. 3/3. All right, so let's do one. Or let's do this one together. This is a good one. Good practice problem. This is about as hard as they get. So let me read the question. And then we'll do part A together. And halas, we're done for today. Okay. 10 grams of oxygen, molar mass is written, reacts with 1 gram. Oh, hold on, guys. 1 second. Mabel. Sorry, I yelled Mabel into the mic there. She hears somebody in the hallway. Okay. So anyways, this is wink, 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 like a very good question to know for your final. So let's do it. We have 10 grams of oxygen. Molar mass is listed. We're reacting it with 1 gram of hydrogen. Molar mass is listed. And the question is, what is the limiting reactant? So what we need to ask ourselves is what chemical will run out first, the hydrogen or the oxygen? If you go online or look at videos or whatever, there's a million different tips and tricks to do this. But again, what I found is the easiest way is to do what we've always been doing, follow those steps we've learned and just do it 2 times. Do it for each reactant. So guys, I'm going to do part A and I'll save part B and C for you guys, and we'll do those parts tomorrow. Okay, so first, balanced chemical equation. You would be given a balanced chemical equation on the test or final, sorry. If you hear me say test, I obviously mean final because there's no more tests. Okay, so here's my chemical reaction. Now, under each element, I'm going to write the information that I'm given in the question. So for hydrogen, I have 1 gram. And I know the molar mass. Luckily, we've given you the molar mass. Okay, so there's that. Perfect. So I can find the moles of that very easily. For this, the reason this question is different than other questions, though, is because I'm giving you information about two reactants. So you need to find out which one is limiting. Okay, so there's my mass and molar mass for oxygen. So obviously, let's start with hydrogen. I'll split my slide down the middle. Okay, so on the left, I'll look at hydrogen. On the right, I'll look at oxygen. Now, before I get started, some of you might look at this and say, hold up. We have 1 gram of hydrogen. We have 10 grams of oxygen. Wouldn't the hydrogen be the limiting reagent? Well, it could be, but we can't compare grams in chemistry. We need to compare moles. So I know it looks like hydrogen is the limiting reagent because there's only 1 gram, but we don't know. We need to look at the moles. Mohammed in the chat mentions grams will be given. Yes, you would not be able to do this question if we didn't give you grams. So grams would be given. Literally, the question will have all of the information that I gave you today. So there'll be no surprises. We'll give you the mass, molar mass. We'll give you the balanced chemical equation. All you guys have to do is this. Part 1, I'm going to find the moles of H2. That's my mass over my molar mass. Okay, so let's see what I get here. So I'm doing this along with you. So 1 divided by 2.01588. I will get 0.49606 moles. Now, I'm not done. This is moles of H2. It still doesn't tell me how much product I get. So next I'm going to find my moles of H2O using my mole ratio. So I take that answer I just got and I multiply it by the mole ratio. Now remember, the mole ratio comes from your balanced chemical equation. And for my mole ratio, you take the chemical that you're looking for. So I'm looking for water, and I'm going to divide it by the chemical that I'm working with. So this will be 2 over 2. So 2 mole H2O, 2 mole H2. And the reason we do it in that order is because now the H2 will cancel. Okay, now the way that works, this is such an easy calculation. We're just multiplying it by 2 over 2, which is basically 1. We get 0.49606 moles. Okay, same thing again, just going to do it with the other reactants. Shadan is bringing up significant figures. Remember, we don't round significant figures until the very end. So we have 3 significant figures here, but I'm not done this question. There's still part B and there's still part C. Don't round your significant figures until the very end, but it will have 3 significant figures. All right, I'm almost done here, guys. Don't worry. I'm not trying to go long or anything, but this is a good place to finish. So now, same thing, moles of oxygen, mass over molar mass. Okay, so again, there's nothing new here. I'm just doing the same thing twice. This isn't new. This isn't hard. This is annoying. That's kind of how I would put this. It's just a lot of busy work, but it's the same thing over and over and over and over. So we get 0.31251 moles of O2. All right, so I want to find the mole of water that will make. So I take my number, 31251, multiply it by my mole ratio. Now this case, in this scenario, it's 2 moles of H2O over 1 mole of O2 because there's only a 1 in front of O2. cancel out the O2. So I take that number and I multiply it by 2, and I'm done. Well, basically, I still have to answer the question, but I am done. I get 0.62502 moles. I'm not rounding yet, not until the end. So guys, you tell me, in the left side, or on the left side, I used hydrogen. On the right side, I used oxygen. Which chemical, hydrogen or oxygen, makes the smallest amount of product? Which chemical makes the smallest amount? Hydrogen or oxygen? What do you think? You got 50-50 if you don't know. Hydrogen or oxygen, H2 or O2? Yep, I got one answer. I got two answers. Perfect. They're both correct. H2, thank you, Shadan and Iman. H2 is the limiting reagent. How do they know that? Well, like, again, it's not hard. It's just annoying. It's a lot of work to show that when H2 makes water, I would only make 0.46 moles. When O2 makes water, it would make 0.62. So I have enough oxygen to make 0.6 moles of water, but I have enough water that only makes 0.49, or we could say 0.5 moles of water. So since the mole of H2O is smaller here, H2 is the limiting reagent, and that's it. We will look at this. It's 3:18, so I mean, I'm done. I got another class after this, and that's enough for today. But we will look at this a little more in detail tomorrow. We'll kind of finish off this question. That was only part A, and that's it for today. So tomorrow we'll look at theoretical yield and the percent yield, and then that's it. We got a little bit to do in chapter 6, but that won't take us long. Iman has a question about the phases. If it's it doesn't matter. Like, phases have nothing to do with it. Solid, liquid, aqueous, gas, that has nothing to do with the phases. We will tell you what to choose. Like, we will ask you which chemical to find the theoretical yield for. So Aman's question is like, do we use solid or aqueous? Which do we choose? You choose whatever chemical we ask you to choose. So like, we would ask you to find the theoretical yield for water or copper. Like, we will ask you. It has nothing to do with the phase. Sure, yeah, I can upload those videos. I can do that right now, actually. I'll upload today's as well. So check your YouTube playlist in an hour or so, and everything should be up. In the last question, Aman, it doesn't say, because there's only one reactant. So because there's only one reactant, there's only one thing you can find. If there are two or more reactants, we have to tell you. Yeah. Perfect. All right. Thanks, Yusra. Thanks, Iman. Thanks, everybody else. Shadan, for helping me out with some answers today. I got another class to go to, so I'll get your YouTube videos uploaded now, and I'll see you all tomorrow. Thanks, Fahad. Thanks, Naval. I got your email the weekend, Fahad. I'm glad you found those quizzes, so thanks, everybody. I'll see everybody tomorrow. Whoop. Bye-bye.